Hi there, this is Coach Suiso and welcome to our virtual demo of our limiting reactant lab. So we've been talking about the concept of a limiting reactant, and today we're going to do a reaction. And what we're going to do is react solid iron filings with a solution of copper 2 sulfate. And that is a single replacement reaction that's going to produce copper metal and then a solution of iron 2 sulfate. So I've got my lab sheet right here that you can find on the Canvas module, and you can follow along as I do it and see what pieces of the procedure that I'm working on. And then I also have in front of me a copy of the lab sheet, and this is what you're going to be filling out and uploading onto Canvas when you turn it in, okay? And you'll notice at the top we do have our data table, so I would advise printing this off before I do the lab so that you can fill out the data as we go. All right, let's get started. So let's look at some of the materials that we've got here. We've got a graduated cylinder. We have a stir rod. We've got a scupula. We have a 150 milliliter beaker. We have a weigh boat. We have our chemicals. We've got distilled water. We have a funnel. And we have a filter. Now we have to supposed to use filter paper. This is actual chemical filter paper that you would use in a formal lab. Unfortunately, this is so dense that it's pretty difficult to get anything through it in a timely manner. And since we typically have to do our labs in a class period, we're going to use something slightly more porous. And this is just your plain good old coffee filter. Okay. And then we also have an electronic balance. All right. So the first step of our procedure is to measure and record the mass of the clean, dry filter paper. So we're going to take our coffee filter and we're going to place it on a zeroed out. And I got it at 0.66 grams. And I'm going to write that down. I'm just going to test that again one more time because this morning it was a little bit lighter than that. 0.66 it is. All right, so that is our coffee filter. Now we're going to measure 6 grams of copper 2 sulfate, okay? We're going to do that on the weigh boat, and it says in the procedure to measure about 6 grams. But that means if we get a little bit below or a little bit above, that's okay. But remember, you need to use the measurement that you get, or in this case, I get in the demo, not 6 grams. It's the exact amount that you get. So I'm going to place my weigh boat on a zeroed off electronic balance. And I'm going to record the mass of the empty weigh boat, which is 6.13 grams, just so I have it. And you'll get all of these numbers, don't worry. So it's 6.13 grams, and then I'm going to zero it off, and I'm going to add 6 grams of my copper 2 sulfate. And remember, this is about 6 grams. It doesn't have to be perfect. So you see this really pretty blue color of our solid copper 2 sulfate here. I'm just going to add it. So that's about 3 grams, 3.78. And we're at 5.2. Oh, that's pretty darn good. We're going to stop it at 5.95 so I don't go overboard there. So our mass then of our copper 2 sulfate that we are going to use is 5.95 grams. So now we're going to put that into our 150 milliliter beaker. So I've got my beaker. I've got my massed out copper 2 sulfate, and I'm just going to bend my weigh boat here. I'm going to tap it all into the beaker. And it's really important you get all of it because otherwise your results might be a little skewed. So we've got it in the beaker. And now we're going to use our graduated cylinder to mass out about 50 milliliters of distilled water. And we're going to add it to this copper 2 sulfate to make a solution. Remember, this will now be aqueous since we've dissolved it in water. So I'm going to pour my water from this jug, and then once I get close to it, I'm going to use my smaller distilled water container to make sure that it's exact. Remember, you always want to get on eye level with your graduated cylinders so you can see the meniscus and make sure that you've got the right amount. That is pretty spot on right there. There we go. So we got our 50 milliliters of water, and let's add it to make our aqueous solution. And I'm going to take my stir rod, and we're going to stir that up, and you can kind of see it's a really pretty blue color. And we're going to go ahead and assume that our salt that we've added, that copper 2 sulfate, is not changing the overall volume. This is still 50 milliliters. All right, while that's sitting there, we are now going to measure about 1 gram of iron filings onto our weigh boat. And so this is my iron filings. It comes in a container like this, and it looks like that. And remember, again, it's about 1 gram. So if it's not exact, that's okay. So we're going to zero out our weigh boat again. And we're going to add about 1 gram of filing here. You can see really pretty iron filings. These are magnetic, so if you were to use a magnet, you could easily pick these up. Here we go. 1.10 grams. So the mass of my iron is 1.10 grams. Pretty darn close. All right, now we are going to do this reaction. We are going to add a specific amount, 1.10 grams of iron, and we're going to add it to our 50 milliliter solution, which includes 5.95 grams of copper 2 sulfate, which is now aqueous. So let's go ahead and do this reaction. So we're going to add our iron in. Make sure we got it all, because remember, we want our reaction to take place completely. And we are going to let this sit for about 10 minutes in order to let the reaction take place. And I'm actually going to use a clean stirring rod, and I'm just going to stir it in there so that we get the reaction takes place as much as possible here. And we are going to go ahead and let that sit for about 10 minutes. All right, so we've waited about 10 minutes for our reaction to take place. And while we're kind of waiting this last 30 seconds to a minute, we're gonna go ahead and get our filtration system set up so that we can easily filtrate our product. So we have got a funnel, and we've got a Erlenmeyer flask, which is perfect to sit a funnel in. And we've got, again, our coffee filter. So what we're going to do is place this coffee filter into the funnel. And now what a lot of people want to do when they're doing this is just shove it in there and hope for the best. But there's actually a way to efficiently do this. So the way you would do it, you're going to fold it in half. Then you're going to fold it again in half, right? So you've got this little triangle. And then what you're going to do is you're going to pull 3 sections of it apart, and you get a perfect cone. And it beautifully fits right inside of our funnel. So we're going to stick the funnel into our Erlenmeyer flask, and we are ready to filter. So what's going to happen, we have our chemical reaction here, right? So let's look at it. We've got our solution, which now should be iron 2 sulfate solution. And then you'll see at the bottom, our iron has displaced our copper from the copper 2 sulfate solution, and now the copper is a solid inside our solution there. Okay? So this was our single replacement reaction. So this copper is the product we really care about. We don't necessarily care about the aqueous iron 2 sulfate because that's simply going to filter through. What we are going to try and figure out is how much copper did we create with this reaction. So because it's a solid, it shouldn't go through this filter paper. So we're going to separate it using physical means here. So let's go ahead and pour our beaker into our filter paper. And we're going to do it nice and slow. Because remember, it does take a second to filter through. And it's going to go quicker than if we were using this filter paper. But it still does take a second. You don't want it to overflow, because that's going to affect your results. So we're just going to go nice and slow. And it's just going straight through. And we can start to see some of the coppers getting caught, which is great. Now you can potentially see that we're gonna have a slight problem if you're watching what we're doing here, because my solution is all going straight through the filter, but I'm catching, some of the copper is not quite going out of the beaker, right? It's catching at the end. So our solution to this is we're gonna take our distilled water bottle and we're gonna just add water to this copper. Now, the reason this, every year that kids panic, they don't want to do this because they feel like they're adding something to the reaction. But remember, this reaction already took place in water. This is an aqueous solution. This water is not doing anything to change the reaction. And any water that ends up on there, we're going to evaporate it off at the end anyway. And we don't care about what's in this Erlenmeyer flask at the bottom, because the Erlenmeyer flask is just catching the leftover. We are not going to be measuring that. So I can add as much water to it as I need to. And it's more important to get all this copper, because we need an accurate result. So I'm just gently using as much water as I need to get all the copper out of this beaker and into my filter. And it looks like we got all of it. All right, pretty good job there. So now go ahead and look down there. You can see that we got our copper inside our filter paper. It was caught effectively. Maybe not perfectly, but that's some human and lab error. But for the most part, we did a pretty darn good job. So I'm going to gently remove my filter, tap out any excess, take my filter paper, and I'm just going to lay it on top of this piece of filter paper. Any paper towel would work. And we are going to let this dry overnight. Okay, so let's just make sure I got it right on there. So there you go. We can see that we've got our solid copper. Here's our iron 2 sulfate solution. And now we're going to let this dry overnight. And when we come back in the morning, essentially the water should have evaporated, right? Leaving us with our product copper. And we'll be able to take the mass and see what our final mass of our product was. We're going to dispose of this in an appropriate container, clean up our lab, and leave this off to the side till tomorrow. And I'll see y'all then.